Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. Every company has a story to tell, from the small startup to the large enterprise, and everything in between. This is one of them. Knowledge is power, now more than ever.
Hello everybody, you're very welcome to a new Redefining Cybersecurity episode here on ITSP Magazine Podcast Network. This is your host Sean Martin, and I'm live-ish, kind of live, from Infosecurity Europe here in London, Excel. And as you can hear in the background, lots of energy about great conversations from the show floor. I'm hearing good presentations as well, and no lack of topics to discuss when we're looking at the world of cybersecurity. And I'm thrilled to have a guest on, Nabil Hannan. He's from NetSPI, and we're going to be looking at the topic of attack surface management. And we're going to look at that in the context of how things have changed over the past few years, where perhaps risk management has changed and how we address the exposure we have in our organizations. So before we get into that though, Nabil, a little bit about you and your role at NetSPI, and maybe kind of an overview of everything that NetSPI offers, so we have that context to start with as well.
Yeah, absolutely. Well, thank you for having me. It's a true pleasure. So a little bit about me, I'm Nabil Hannan. I work at NetSPI as the field CISO, and within my role, I spend a significant amount of time working with executives from various organizations, mostly clients and prospects, to understand challenges that they're facing on their day-to-day roles of managing risk, and understanding what type of solutions they're trying to work with and find the best strategy for reducing risk given their business context and the business objectives that they have. Yeah. NetSPI, we are one of the global leaders in offensive security testing. We've been around for over 20 years with a pedigree in penetration testing. So over the years, we've been testing various systems, trying to look for vulnerabilities and helping organizations address them and fix them. We have a team globally of 250 plus testers who day to day, that's their job, is actually testing and looking for vulnerabilities on various systems. We specialize in different verticals from a client perspective, and we've also specialized in different service lines that we offer. So our testers have very niche specializations that include and range all the way from web app testing, network testing, all the way to testing hardware such as ATMs or medical devices. So that's our key focus and mission today.
I love it. And so if I may, because I remember, I go back quite a ways, system engineers, aka sales engineers, to me were like the perfect role within a security company, trying to help organizations secure their business. And I love the new role of the field CISO, because you have that view of what's the business objective, what's their strategy to get there, how do you help them do that securely with the technologies and services that are available to them. And it's a completely different way of thinking about it. And so I want to, if it's okay, to start with this point of what some of the conversations are like with you and your peers in the CISO role that you're talking to, because I know a lot of them struggle with vulnerability management to enabling business, right? It's a big jump from those two things. So tell me about some of those conversations. How do you help them bridge that gap?
So a common thing we've noticed within the industry is, just like there are different maturity that organizations are from their security objectives, you also find that there are also different maturities of CISOs in the industry and how they approach the problem. There are some CISOs that are very technology heavy, so they end up buying a lot of tooling and automation in the hopes that it's going to solve all their problems. And then you have other CISOs that are maybe a little bit heavy-handed on building solutions and solving problems internally only, versus going and buying solutions but building them in-house because they might have a business need that's very niche or unique. We tend to see more of those things in a lot of the high-tech firms, as an example. You know, the Googles of the world, the Amazons of the world, the Netflixes of the world, they are truly building solutions that are net new and are at the bleeding edge of things that are out there. So often traditional testing tools and techniques don't work for them, so they actually end up having to build their own testing techniques or build their own tooling that has the scalability and reliability to test what they need tested properly. So a lot of my conversations with the CISOs vary drastically given their maturity, and their maturity is often tied to the maturity of the cybersecurity initiative within their organization. My key message with most of these peers of mine and colleagues of mine is, let's figure out what makes the company money, because that's ultimately the business goal that you have, is to make the business successful in what it's trying to do. And let's figure out how to enable the business to what they do better, but in a secure fashion. And that often leads to much more deeper conversations around whether there needs to be more focus on the governance side because you're heavily regulated as an industry, or whether there needs to be some development of custom technology because you're a high-tech firm and you're building, I don't know, Apple Vision Pro, which doesn't exist before, and you don't know how to test it, so you have to build your own testing framework on how to test augmented reality and virtual reality systems. So the conversations vary, but ultimately, from my perspective, it comes down to where is the business need and where is the money coming from, and what is your true risk objective that is aligned with your business objective. And based on that, you come up with decision criteria on how you're going to approach your cyber strategy overall.
Yeah, super cool. I just love the role, and I like that.
I love it too. That's why I'm in it.
I like that those conversations are being held. So, in the context of attack surface management, then, how do those conversations? I mean, let me just say this. I think it's one thing to understand where the risk is, looking at vulnerabilities. Maybe you can even look at misconfigurations and things like that. But when you start to get into nuanced areas of bespoke applications being built and where all these changes come, to try to mix commercial stuff with in-house stuff and the terminology and the results of the findings and pulling all that together in a meaningful way, I feel ASM probably does a better job of painting a better picture, consistent picture across anything and everything. Am I right in that? And maybe if you can expand on that a bit more.
There's a few things we've seen as trends in the industry, and we are at a point where we really have to review those trends and understand what approaches make most sense in today's ecosystem. So if you think about, let's say, software development methodologies, what used to work 10 years ago, based on how we built software, doesn't work anymore today. 10 years ago, the hype was like waterfall, SDLC. Today, the hype is agile. Categorically different approaches to building software, but now agile brings its own set of challenges as well from a security perspective because of rapid deployment, rapid changes in feature functionality, code being deployed in production hourly, daily, weekly, depending on what your cadence is. The risk exposure and the visibility of risk from the outside now is also changing at a rapid pace because of agile, because of adoption of CI/CD pipelines and being able to go from the developer's keyboard to production in a matter of minutes if needed.
Yep.
So the way attack surface management has been traditionally done isn't working, and that's why we came up with our own approach to attack surface management. Traditionally, organizations were of the mindset that you can buy tooling and automation and run it against your external facing perimeter at all times and find problems. The problem you have with tools, just like any tools, is number one, they're noisy, so they report things that are maybe not truly issues. Number two, a tool is a tool. So you need someone to actually go manage that tool, whether it be how it's running, what is it reporting, if it's truly an issue, is it a false positive? If it is truly an issue, then now we have to chase it down. So just deploying tools isn't enough, because it only adds more burden of work to your organization now.
On both sides, right?
On both sides, both on the tooling side and
feed it with the data and
remediation and addressing it. So our approach to attack surface management is we already have a group of 250 plus testers who are security experts and who know how to interpret and analyze the results from these tools. We can now build and focus on building a platform with automation that accelerates and identifies indicators of areas that need attention, and our testers can go validate them and not report all that noise to you, but report to you true issues that need to be addressed. So in that type of an approach, you now don't have to go hire someone to go run and manage a tool, or hire a team to go manage your attack surface. NetSPI can take care of that for you. When you get an issue reported, you know it's a true issue that has to be addressed. And we are constantly doing that 24/7, 365 days a year. And also, we're discovering the unknown. You know, with software and people's ecosystems changing so quickly, with cloud environments that can pop up assets that show up for 10 minutes and then go away, we have the ability now to keep an up-to-date inventory of your external perimeter to make sure that we are monitoring those and looking for issues and exposures in those environments. And when they go away, we stop monitoring them because we know that they've gone away. It's what the attackers are doing, so you have to do what the attackers are doing too. So that's what that's how we're approaching it. The other thing is, attackers aren't stopping, right? They're not limited by time, so you can hire a pen tester to go test something for a week and then be like, okay, you found 4 vulnerabilities, great. The attacker needs 1 vulnerability and they have unlimited time. The pen tester is handcuffed to a limited time to try and find as many things as possible. So with that approach, you need a truly continuous view of your external facing perimeter. And you know, a lot of organizations are also limited on what they can test. So for example,
in terms of scoping?
In terms of scoping, but also from a testing perspective. So you may be buying commercial off-the-shelf software that you're deploying. You don't have any control over how to fix that code. You don't have any control over what vulnerabilities that organization may have inserted in there, if there's a 0 day in there. You maybe have control over software you're developing. So organizations often test their software regularly and fix their software regularly, but attackers don't care whether you developed the code or someone else developed it. If you're using it and deploying it, they find an issue, they're going to use that issue to compromise you. So that's where the attack surface management comes in really handy, because we also now don't limit ourselves to what you gave us as the scope. We are looking for everything that's potentially facing the internet that belongs to you, and we now have the capability to analyze those for potential exposures.
And I know one of the things we also could potentially talk about is APIs. So I don't know how that fits in, because there's 2 parts of this, right? APIs that you provide through your application as a service that may be exposed to the internet so others can use it, and then using other APIs to make your app better. Right? Yeah. So how does that fit in?
Everyone has APIs now, right? Yeah. It's almost like the table stakes for doing business today is you have to expose some sort of an API from your system so others can sit automatically, programmatically get data from your system, or invoke certain functionality within your system that they want to do for their business needs. Now, the problem you have with APIs is that when you're building APIs, you're building software in very bite-sized components. And you're building these components to be reused. But the challenge you have is you may or may not know how someone is going to reuse that component. So often the challenge developers have when building APIs is they don't necessarily understand how something may be used, they're probably building the API to solve a problem that they're trying to solve. But I'll use a simple example. If you're building an API that picks a random number, using that for a video game may be okay, but if all of a sudden you start using that for cryptography, if it's not a cryptographically strong random number generator, it may not work very well.
Right.
But as the developer who's building it, he may have built it for one purpose, made it available over the internet, and who knows how someone else used it. I was having a fun conversation with two of my colleagues today who was just trying to understand what an API is. And I used a fun example from the Mars rover that crashed in Mars, the very first one. And what I was explaining to her was APIs get built and you can often test them individually, but they can have funny behavior if not tested on how they work together in an overall system. So the Mars rover, as you can imagine, anything going to space is getting tested pretty thoroughly. And they tested different components of the rover separately, but not together. So the lander had an API call that was expecting the distance for the thrust to allow the ship to go down in meters, but the API that was sending that data was sending it in feet. So obviously if you test each of those components individually, they work, but when the API is sending you distance in feet and you're expecting it in meters, when the API says go down 10 feet and you go down 10 meters, you crash into the surface. So that's an example of how simple functionality within APIs, if not architected or used correctly, can have adverse side effects in the long run.
Yeah, I love it. I was thinking that's a great example, and I was thinking things like authentication and scaling. If it's expected to be used once and it's used 10,000 times, is it going to hold up? And
well, authentication, authorization in themselves are a challenge even without APIs. Right. APIs just add more to the complexity now because you just don't know how the API is being called. If you look at the new OWASP top 10 for APIs that's been published, the lack of authorization checks, I believe, is number one.
Yeah.
And what I try to explain to people is this: our traditional methods of authentication and authorization are getting outdated, and in fact they all have their own flaws. So I think the username and password model has served us well. It did what it needed to do, but we're getting to a stage where we have to truly envision how to properly authenticate a user and, equally figure out how to authenticate requests, queries, and determine what type of authorization you have to perform those. So we're seeing advancement in technology, especially with Apple has a new thing called passkey, which is cryptographically strong way of doing authentication. I feel those are the types of things that we'll have to see how it evolves to fix just the generic authentication authorization challenges we have today. And then from the API perspective, I think we're going to start seeing more and more development and adoption of secure by design frameworks that take the onus of doing authentication and authorization away from the developers, so it forces them to build things in the correct way from the get-go and simply not allow them to build software if they're introducing vulnerabilities to begin with. So we'll start seeing more and more adoption of that. It's very hard to do today because of all the legacy systems and technology restrictions and complexity of systems, but over time I think we're going to see a paradigm shift on the development process itself.
Yeah, I'd say so. Let's, as we wrap here, Nabil, maybe let's kind of bring it back to the bigger attack surface management picture again, and maybe either a scenario to help bring the point home for your fellow CISO, or maybe just a piece of advice for them as they rethink ASM as part of their bigger InfoSec program.
The discussion that I have most often with CISOs today, especially around ASM, is it truly is the bare minimum benchmark of what you need to do to protect your organization. You can test assets internally, you can test things in QA environments and so on, and you should. It's all about defense in depth, and you should find different ways to defend your environment. But ultimately, the attackers are coming in from the outside. If you don't know what you have on the outside, and you don't know whether they're actually configured correctly or if they have certain weaknesses, then you're going to be left with exposures that absolutely will get exploited. It's not a matter of if, it's a matter of when. And as a result of that, I think ASM is soon going to become an absolute bare minimum entry into cybersecurity, where if you're getting started today and don't have anything in place, attack surface management is probably the first place to start, just to understand what your perimeter looks like and what exposures you might have.
Yep. And I love the point that, it's always a question of when you start to bring others in to help with the problem, it's not a dumping everything over. It's having the good basics in place first. Good hygiene in place first.
The hygiene thing is a good example. I use that many times where, I wake up in the morning, I shower and I brush my teeth every single day. That's attack surface management for me. Yep. I still need to be eating well, I need to exercise, I need to have good mental health and so on. Those are secondary, but at a minimum, just for basic hygiene, I have to start with something, make it part of my daily routine. That just has to become second nature. And from a hygiene perspective, I think that's a relatable example that I like to use.
Absolutely. Well, this has been great, Nabil. I appreciate you joining us here today, and hope you have many more conversations like this with others. And of course, we hope people listening to this are thinking differently about ASM and maybe even APIs and how they build their own apps. And
I appreciate it. Thank you so much for having me.
Very cool. Thank you.
We hope you enjoyed this conversation. If you learned something new and the story made you think, then share itspmagazine.com with your friends, family, and colleagues. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.